Elena Williams is a young bureaucrat who works in the finance ministry of an island nation which is circular in shape. At present, the 4 busiest work hubs of the country lie on the coast, while the majority of its citizens live near the country's center. Metro lines have connected A to B and C to D for many years, but recently the government installed a new line from O to Y such that OY is perpendicular to CD. No single initiative has ever boosted the economy so dramatically. The commute is faster, cheaper, and cleaner than ever before. Consequently, the government is pledged to sponsor a similar metro line for people traveling between point O and point X, such that OX is perpendicular to AB. Elena's boss, the finance minister, is overseeing the cost of construction, but the figure he has quoted is shocking to say the least. The price tag is kept 20 times greater than the cost of the first metro line. Knowing that the project will be greenlit no matter the cost, she suspects the finance minister has grossly inflated the numbers so that he can pocket the surplus for himself at the expense of the taxpayers. But before Elena can blow the whistle on this scam, she must find out the exact distance between points O and X. After all, the cost of construction is directly proportional to the length of the metro line. If AB and CD form chords of equal length and the length of metro line OY is known, can Elena compute the length of the proposed metro line OX? If so, prove how. We know that line segment OX is perpendicular to AB. In other words, OX can be imagined as the height of triangle OAB, where AB acts as the base. Since the area of a triangle is half times the product of its base and height, we can express the area of triangle OAB as half times AB into OX. We can rearrange these terms to express OX as twice of this area divided by AB. This means that in order to find out the length of OX, we must first find the area of triangle OAB as well as the length of its base AB. To do this, let's focus on a similar line segment OY, which we know to be perpendicular to chord CD. Here again, we can imagine OY to be the height of triangle OCD, where CD acts as the base. This means that the area of triangle OCD is equal to half times CD into OY. So far, we have derived 2 expressions, one that represents the length of OX and another one which represents the area of triangle OCD. What we really want to calculate, however, is the area of triangle OAB. Well, if you look carefully, triangles OAB and OCD have a lot of things in common. For instance, chord AB is given equal to chord CD. Besides that, we can say that line segment OA is equal to OC and line segment OB is equal to OD. This is because radii of the same circle are always equal to each other. Mathematically speaking, triangle OAB is congruent to triangle OCD. This is because whenever all 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle, then the 2 triangles are said to be congruent by the SSS criteria. As a result, the area of triangle OAB will also be equal to the area of triangle OCD. Or should we say the area of triangle OAB is equal to half times CD into OY. We can now substitute this value in our earlier equation to compute the value of OX. In fact, let me place both these equations next to each other to make it easier. On doing so, we observe that OX is equal to 2 into half times CD into OY all over AB. To simplify this further, we can substitute AB as CD in the denominator. At first, this gives us a rather lengthy expression on the left-hand side of the equation. But if we cancel the 2 present in the numerator with the half present next to it, and cancel out the CD present in the numerator with the CD present in the denominator, we'll be left with just OX being equal to OY. In general, this proves that chords that are equal in length are also equidistant from the center. Given that the two metros stretch across similar landscapes, the actual cost of building OX should be approximately equal to the cost of building OY, certainly not 20 times greater. As Elena posts her proof online, the truth goes viral. The corrupt finance minister is jailed, and the new metro line ends up costing no more than the first one. Elena is a darling of the people, but her good work has only just begun. Now that we know that chords that are equal in length are also equidistant from the center, tune into our next lesson to find out if the converse of this theorem can be applied to undo the side effects of a crazy wormhole experiment gone wrong.